Hi guys, welcome back to the channel. I hope you all are doing good. So in this video, we will be solving a very interesting and slightly tough problem. But before we begin solving the problem, I would like to tell about this ebook. This ebook is on data structures and algorithms. It is written by a software engineer who has himself worked in a lot of multinational companies. And it contains 90 plus DS algo chapters with 15 plus HR questions also. So if you're preparing for coding interviews and all, it will be very helpful. So I will just quickly take you through the book and show you how neatly and well organized it is. Uh, Sorting algorithms are there. Before that, there is introduction part and searching algorithms, basic data structures, all are there. Stacks, queues, linked lists, trees, graph, everything. So if you want to click on something, for example, implementation of BST, so directly it will lead you to that page and you can have a look at everything. The code is given and also pictorial representations will be there in the book. So this book is available for a very affordable price. The link is in the description. Please do check it out. So let us see today's problem. Today's problem is called distance of nearest cell having 1. So given a binary grid, it means a matrix which contains values 0 or 1 only. Find the distance of nearest one in the grid for each and every cell. So nearest one for each and every cell we have to find. How do we do that? So let us say, I think I should insert a table only over here. Or maybe I'll just draw it. So if there is a matrix like this, 0, 0, 1, 1, 0, 0, 0, 1, 0. Okay. So if this is the matrix, then for this matrix, we should tell for each and every cell. So each and every cell, what is the distance from the nearest one to that cell? So for example, if we consider this cell, okay, the nearest one for this cell is at a distance 1 because 1 is over here only. So this distance from this cell to this cell is 1. So let us fill 1. What about this cell? Again 1 because 1 is present here. Okay, for this cell, what about this cell? For this cell, the nearest cell is 0 because this cell itself is 1. Okay, similarly for this 0, for this 1, for this 1, for this 1, for this 0, for this 1, like that. So this is our answer. How do we get this now? That is the question. So I think you have understood what the problem is asking us to do. Okay. Now, how do we get? That is the thing, right? So we can apply two approaches over here. First approach is we can use BFS, breadth first search. And second approach is actually something very interesting, and I will tell you that. So watch the entire video. Let us see breadth first search approach. In breadth first search, what will we be doing is we will find out all the cells which have a value 1 and store the coordinates of that cell in a queue. So whenever we do breadth first search and we want to do iterative solution, we want to get an iterative solution for it, we use queues. For DFS, we use recursion or stack. So you can remember it like that. So what will we be doing is, basically I will be telling the first approach, which is going to be BFS approach. For BFS, we will be using queue. Okay, we will be using a queue. what will we store in the queue? Basically, we will be storing the coordinates of what? Coordinates such that matrix of I comma j, matrix of I comma j is equal to 1. Why do we need these coordinates? With these coordinates, how will we do breadth first search? See, if you have read the problem completely, it says we can go either up, down, left or right. Okay, we can go either up, down, left or right. So for each and every coordinate having a value 1 in that cell, I will check. So suppose this is the cell, I will check to its right, left, up, down. I will check in all the 4 directions and try to find out if there is a cell which has a value 0. Or basically what I'm trying to do is, in each and every adjacent cell corresponding to a cell which has a value 1, I will try to change its value to the uh, possible answer. Let's take an example and see what I'm telling. So suppose the matrix that we have taken is this. Okay, suppose this is the matrix that we have taken. Now, if you consider this element, if you consider, for this element, I will check right, left, up, down, and I will try to change the value in a different this thing only. I will try to change the value such that it will represent the nearest distance for this cell from this cell. So for this cell which has a value 0, I will modify this cell's value in another vector. Actually, not modify inside this grid only. I will make another grid. Let us call it answer grid. Okay. I will make another grid, answer grid, and in the corresponding cell which corresponds to this coordinate, I will change its value over here to a value which will be showing the nearest distance of this cell from this one. So I don't think you have completely understood, but let me see. Let me see how can I make it better for you. So we have this matrix, right? First of all, what I will be doing, let me actually go parallel with the code only. See, first of all, what we will be doing is, see, find out. So we are given a, what are we given actually? We are given vector of vectors. So basically, this is just a grid. It is called mat. Okay, so now the number of rows is n, number of columns is m, and I have declared another vector answer, and however I declared it, it has n rows and m columns, and each cell has a value int max -1. Why -1? I will tell you. Basically, it is just to avoid overflow. So what is this? Until here, let us summarize now. Until here, let us see what we have done with the example that I have taken here. So with this example, let us see what I have done. I have made an answer vector which stores the values like this: infinity, 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 and so on. And what is the size? Same size as the input matrix, same. So basically this is having the same size, both of them. Okay, so both of them have the same size, but each and every cell value in this answer matrix is infinity, some highest value. Why infinity? Because I want to find minimum. It is better to assume infinity in the initial phase. Now I have taken a queue and look at what is the this thing type. It is type in pair. Why pair? Because I need the coordinate I comma j is pair, right? So that is why queue of pairs. And now I am traversing through the input matrix, and wherever I find mat of ij equal to 1, I am pushing that particular coordinate in the queue, and I am this thing changing answer ij to 0. So basically what will happen here, so if we analyze carefully this value here, for example, see mat of ij is 1 now, so answer of ij will change to 0, and we will push, so the q will have the coordinate 0 comma 2. So q will have the coordinate 0 comma 2. Like that we will do for this one, all the cells in the input matrix which have a value equal to 1. We will put it in the queue and change the value to 0 in the answer matrix. So let me write clearly in a better way. So let us say, let us just assume some random matrix. Okay, so this is my input matrix. So this is my input matrix. And how is my answer matrix going to change now? Wherever 0 is there, it is infinity. So wherever 0 is there, it will be infinity initially. And wherever 1 is there, it is going to change to 0. So we are assuming infinity, which means that the distance from the nearest cell is initially assumed to be infinity only, some very large value. Okay, so let me just fill it, and I have filled it now. And now what we will be doing, how is our queue? So our queue contains what elements? Our queue has these 0 comma 2, this is coordinate, then it has 1 comma 0, then it has 1 comma 2 and 2 comma 1, as well as what is it, 3 comma 2, I guess, right? Yeah. So this much part is done. This much part is done. Now we will be doing breadth first search. See, we'll be doing breadth first search until the queue size is not 0. That means all the possible index values have been checked. What will we do? We will take the first element from the queue and declare two variables x and y, basically the coordinate x and y. So q dot front dot first, q dot front dot second, and pop it out. Pop out the first element. So over here, first element is this one. First element is this one, and this element is popped. So 0 comma 2, let us write separately. Okay, 0 comma 2 is written separately. And now what is this dx vector, dy vector? So basically what we will be doing is we will be checking to the left, up, right, and down of the cell that we have taken here. This x comma y is a cell. We will be checking to the left, right, up, down. You can do this in multiple ways, but I've just taken array. And what is this? -1, 1, 0. So I think you all know the Cartesian system, right? You all know the Cartesian system. And basically in the Cartesian system, if we have to go, if we have to represent something to the right of origin, it is like 1 comma 0, and down it will be what, 0 comma -1, then left it will be -1 comma 0, and up it will be 0 comma 1. So these values only are represented in this vector here. So in this array it is represented. See, -1, 0, 1, 0, 0, 1, 0, -1, like that. Now I am running a loop for just checking these four values. So this is simple. I think you can understand this. Just checking the neighbor only, just checking the neighbor. So neighbor x coordinate, neighbor y coordinate, I am storing. So what is neighbor x and neighbor y? It will be x plus this value. So this value can be -1, so it will become x minus 1. It can be 0, so it can be x equal and nx equal to x also. So that is why I have made use of these two arrays. It will make coding easier. The writing code will become easy. And obviously we have to check if it is a valid cell or not. For example, if we can't check outside over here and all, no? So we have to ensure it is a valid cell. So this statement is ensuring that it is a valid cell. Next, now I am updating the answer matrix for the neighboring cell. I am updating the answer matrix for the neighboring cell. How? If answer of neighboring x and neighboring y is greater than answer of xy plus 1. So I'm just checking for the distance. So let us see what this means with this example. Suppose now I'm doing 0, 2. So where is 0, 2? I'm checking for a 0, 2, right? So 0, 2 is over here. Here. Now I can only check left and down. Right and up can't be checked because the index will become invalid. So check down. If I check down, what is answer of down? What is down of this? What is down of this coordinate? Down of this coordinate is this, which corresponds to this cell. Now 0, see this cell is 0. Is it greater than, what is this cell? 0 plus 1? No. That means we don't have to update this cell. So this cell we don't have to update, leave it. Now check this cell, because we can check to the left of this, it is a valid point. Now see, this cell is having value infinity, infinity minus 1. So is infinity greater than 0 plus 1? Yes, infinity is greater than 0 plus 1. That is why now I am changing. So now I am changing that coordinate to 1. So now you can observe this infinity over here will be changed to 1. What does it mean? It means for this cell, the nearest distance from a 1 is equal to 1, which is correct. So we have got the answer for this cell. But most important thing is we should push the coordinate of that cell inside the queue, because it will help us find out the remaining cells. That is how we are making use of breadth first search. This answer that we have got, see, this answer is 1. It will help us find this one. See, just think about it. It will help us find the answer for this one, right? So what will be the answer for this coordinate that I am on? Infinity is greater than 1 plus 1. Or you can say from here also, if we take, what will it be? 0 plus 1. So this will change. So ultimately what is happening, if we have changed a particular coordinate value in the answer matrix, we should put that coordinate back into the queue. It will help us for the next answers. It will help us to find out the next answer for the other coordinates. So that is what I have done. I have pushed it back. Okay, I have pushed it back, not pushed it back, sorry. I have pushed it inside the queue. What? Nx and y. Nx and y are neighboring coordinates. And I have changed, I would updated the neighboring coordinates answer matrix. Answer matrix basically tells the distance for each cell from nearest one, that's all. Then I am just returning the answer matrix. So until queue size does not become 0, it will continue to happen. So like this, it will happen. Take an example and do. It has become a little untidy because space is less here. I hope you can understand. But I tried my best to tell you what exactly is happening. You can do it for the entire matrix. The remaining matrix anyway, you can do it now. You have understood a little bit at least. So, okay, let us forget all this. So this was the breadth first search approach. I hope you understood how to use BFS. Basically, we make use of queue. Okay. Let us see another approach. Now, this approach, you don't need a queue. Basically, you need only answer matrix and you don't need a queue. And if you're still wondering why it is int max -1, because it should not overflow. Int max might overflow, so there is a chance it might overflow. That is why int max -1 I take. Now let us see another approach. What is the another approach? Another approach is, first few steps will remain the same. For example, let us take this. Let us take this as our input matrix. Okay, this is our input matrix. And let us now fill our answer matrix. So our answer matrix is, I would encourage you to do it with me. It will be nice. Just take a pen and paper and dry run now. So our input matrix, initially it will have infinity everywhere in each cell. We are just assuming this. You can assume any higher value also. Not any higher value, it will be out of flow. Any high value. Infinity everywhere. Okay. Now what we are doing? Now now we are traversing through the input matrix, and wherever we find 1 in the input matrix, corresponding to that in the answer matrix, we are making it 0, which again we have already done this, because it means that it is showing what? It is telling us that the distance from that cell is 0 to the nearest one is 0, which is correct only. So now I have to change these values. So these values will change. I'll just erase that. Okay. And so now I'm using a pen tablet. Actually, I don't think you can see the pen. Just tell me in the comments if it is little more organized now. I'll try to improve my writing and everything, but tell me if it is better, you are liking it. So now I'm changing the values to zeros here in the answer matrix, wherever 1 is there in the input matrix. Now what I will do, I will now traverse through this input matrix. Sorry, answer matrix. Let us concentrate on answer matrix. But we should also concentrate on input matrix as well. So what are we doing now? Wherever we find a cell which has a value not equal to 1, which means basically a cell having 0 in the input matrix. Wherever the cell has a value 0 in the input matrix, let us concentrate on that. So for example, this cell has a value 0. What are we doing? Corresponding to this coordinate in the answer matrix, we will be checking in all the possible directions, left, right, up, down, and trying to change its value. For example, we can, if we are over here in this index, we can check here and here. What will we check here and here? We will basically check if the value in this coordinate, is it greater or lesser than this coordinate plus 1. Why plus 1? Basically, it will tell us the distance from the nearest one. The intention is that only, right? So we do plus 1 because we have to move from this coordinate to this coordinate. To move from this to this, we need 1. That is one distance. Similarly, from here to here, it will be one distance, right? So what are we checking basically? We are checking answer of ij. We are comparing answer of ij with what and what? With answer of I j plus 1 plus 1. Answer of I j minus 1. Answer of I plus 1j. And finally, answer of I minus 1j. Basically, in all the 4 possible directions, we are checking plus 1, plus 1, plus 1. So like this, we can keep on updating the matrix. So let us see how it will happen. So I will show you how it is going to happen, what I'm saying. Okay, so initially we are over here, and this is infinity, and this is also infinity. So infinity, is it greater than infinity plus 1? No. Similarly here, is it greater than infinity plus 1? No. Now go to this cell. Go to this cell which is having coordinate 0, 1. Now check, is infinity greater than 0 plus 1? Yes. Is it greater than 0 plus 1? Yes. So basic, and is it greater than infinity plus 1? No. So this value will now change to be 1. Okay. Now, so this is 1, so we don't do anything. Go to this cell now. Check over here, infinity. 0 plus 1, is it greater than infinity? 0 plus 1 greater than infinity? If anything is greater, if infinity is greater than any of them, sorry, is infinity greater than 0 plus 1, I should say. If infinity is greater than any of the adjacent values, if the corresponding cell's value is greater, then we change it off. So this also becomes what? 1. So this becomes 1 now. Let us go here. See, this also will change to 1 only. And if we go here, this also will change to be 1 only. Now look at this one. Concentrate on this coordinate. Now infinity, we are comparing infinity with how many possible values we can compare? We can compare with this and this one, top and left. So infinity is greater than 1 plus 1, of course, and to the left again 1 plus 1. So this value is changed to 1 plus 1, 2. So if you observe, for this cell, nearest distance from a corresponding one is obviously 2, right? So we can go like this, we will reach 1, or we can go 2 steps up, we will reach 1. So for this cell anyway it is 2. Now fill this. So you can fill this, but this will be incomplete. See, now we did an approach from the top left corner, we are going to the bottom right. So some of the cells might be untouched. Some of the cells might be untouched. There is a possibility that we are not touching upon some cells. So what to do? We did from top left to bottom right. Same thing you do from bottom right to top left. You will get the answer. Whatever I did now from top left to bottom right, do the same thing from bottom right to top left. So that is what my code is. Explanation has become very lengthy, I would say. Video is lengthy, but I hope you are able to understand. So I will just copy this and show it in my Sublime text only better. See, what is happening is, I hope you have understood everything till here. The answer matrix, matrix ij, everything. So basically, if matrix ij is equal to 0 or equal to 1, whatever, not equal to 1, I am just checking for all the safe indices, all the safe coordinates. If j minus 1 greater than or equal to 0, I do not want to go outside the matrix, that's all. So I am just checking each and every possible, in all the 4 directions, whichever cell is possible. And I am updating my answer a of I and a of ij. But this is from top left to bottom right. Now do it from bottom right to top left. So this is bottom right to top left, same thing. Why are we doing this? Because some cells might be untouched. You might not have gone upon some cells only. The answer, not gone upon some cells mean like you might not have got the answer correctly for some cells. That is why you should do this. So if you want me to submit, I think it will work. I don't know, it had worked when I had done. Let me see. I don't know why it's, yeah, so it is correct. So this was the second method. I hope you all understood and you like my explanation. So please hit the like button. It will really motivate me. Subscribe, that will even more motivate me. And share this video with all your friends as much as possible. You will find all the links in the description of this video. You don't need to worry. Okay. All the answer, solution, my Instagram, LinkedIn, everything is in the description. Thank you for watching. Take care, stay safe, keep learning, keep growing. Stay tuned. Bye.